Okay, in this video we're going to be looking at the nth term of a sequence. Now, a formula can be a very powerful tool to store all the information you need for a sequence. So I've got an example here, and we have u subscript little n, this is equal to 3n plus 2. Now this is a formula that tells us for every value of n, it tells us what the term at the nth position in the sequence is. So for example, if we put n is equal to 1, then we get u1, this is the first term in the sequence, and we just plug in the value of n into the formula. So we get 3 times 1 plus 2, and this just equals 5. So this formula has told us what the first term in the sequence is, and this is just 5. And we can do this for every value of n, so this is why it's so powerful. We can do this for 2, for example, 3 times 2 plus 2, that's just 8. And if we do this for n equal to 3, you get the idea, it's just 3 times 3 plus 2, that's 11. So another way to write this is in the normal notation for sequence, so we have 5, 8, 11, and etc. So this formula right here is generating this sequence, right? And it also tells us the value of any term in the sequence, so you can put in n is equal to 100, 1000, whatever you want, and it'll give you a number for what that term is in the sequence. So now we're going to look at a few problems involving the nth term formula for a sequence. So a common problem that you may be asked is if we're given a sequence, so if we're given a sequence formula, for example, un is equal to 5n minus 2, and we're also given a term in that sequence, so let's just write this as un is equal to 153. So the problem might be find n, right? So we have this sequence, and we are given a number that appears somewhere in that sequence. And, write n here. So the problem is finding what position in the sequence does this term appear. So we can firstly look to see what this sequence looks like just by plugging in a few values of n. And we start at n is equal to 1 and we build up. So for example, putting n is equal to 1, we get 5 minus 2, that's just 3. And then n is equal to 2, 10 minus 2, that's 8. And then 15 minus 3, 2, that's 13. So this sequence generated by this formula, this is what it looks like roughly, so for the first few terms. And then we're being told that 153, this appears somewhere down the line. Right, and the question is, at what point down the line does this term appear? So the way to find the solution isn't as bad as you think. We just set these two formulas equal to each other. So we write 5n minus 2 is equal to 153. And now we just solve for n. And solving for n is going to give us the position, the nth term, so the position in the sequence where 153 appears. So if I just add 2 to both sides, we get 5n is equal to 155. And then just dividing by 5, we get n is equal to 31. Right, so we know that at the 31st term in the sequence, we're going to get 153. So this is kind of the method of solving a problem like this. We just set the formula equal to the number in the term. And now we're going to look at a bit of a harder example. So now let's look at a harder example, and this time the sequence is going to be given by this formula, n squared minus 7n plus 12. So this time it's a quadratic, and we want to find out what position in the sequence does the term 72 appear. So just like before, we're just going to set this sequence equal to the term, so the formula equal to the term. So if we do this, we get n squared minus 7n plus 12, and this is equal to 72. And now we are just solving a quadratic, right? So we want to find the values of n for which this equation holds. So if we just subtract by 72 off both sides, we get n squared minus 7n minus 60 is equal to 0. So observing that 60 is 12 times 5, we can factorize this quadratic as n minus 12 times n plus 5, and this is equal to 0. And if you didn't spot this straight away, you can just complete the square or use the formula, and it's going to give you exactly the same answer. But if you can spot it straight away, it's going to be a bit quicker. And now we can just read off what the solutions are. So we set each bracket equal to 0, and we get n is equal to 12, and n is equal to minus 5. And now the last step is to think which of these solutions makes sense, right? So we've got a positive number and we've got a negative number, but in a sequence we're only interested in positive indexes. So we start at n is equal to 1 and we go along through the whole positive integers. So we're not really interested in what a negative term is. So this, we just cross it out, ignore it, write no solution, and our solution is in fact n is equal to 12. So in the 12th position of the sequence, we're going to find 72 as the term.